Good afternoon, everyone, and welcome to today's webinar, Opportunities Surrounding IIoT for Food Manufacturers, organized by FPSA member Blendtec and hosted by Matt Hartman, Senior Automation Sales Engineer and FPSA's Chairman of our New Technology Network. Before Matt introduces our guest speaker, Scott, let me just go through a few quick items. The webinar is being recorded, so you can listen in again at any time. And if any of your colleagues didn't have a chance to today, it lives within the website members only section, so they can listen to it at any time during the year. All of you are muted by default, but you can send in questions anytime. Just type them into the question pane. I think it's to the right of your screen, and we will address them as the webinar goes on. So I think we're all set. Matt, I'm gonna kick this over to you, and thank you again, everyone.
Thanks, Dolores. Well, I'd like to welcome everybody to our first webinar about our continuing education series on implementing the Industrial Internet of Things. Today we have Scott Whitlock. He's the president and CEO of Flexware Innovation here in Indianapolis. I've worked with Scott since 1994. We started working together, collaborating together at a small company called Indiana Automation back in the day. We've worked many projects together. Flexware's specialty is the MES layer, the manufacturing information systems layer. And I thought it'd be a good place to start this conversation off with Scott and see where he sees the Industrial Internet of Things going. And hopefully we'll have a great conversation. Please submit questions as we move along, and we'll be happy to address them as the conversation moves forward. Scott?
Okay, Matt, as we practiced, I just want to make sure everybody can see my slides. So I'd like to see you, Matt. Can you see the slides there on the screen? Everybody good?
I can see the splash screen.
All right, excellent. So here we go. Thought we'd do just a little bit of education for everybody on Industry 4.0, IIoT. We've got some acronym slides here too, just to level set everyone. I think most people who are familiar with this, with these slides, recognize the Industry 1.0, 2.0, 3.0, and now we're into this Industry 4.0 or Industrial Internet of Things. And so I just want to kind of give everybody a quick history view of that. I'd say we are just now starting into this 4.0 revolution. You know, it's labeled as cyber physical systems, the Internet of Things, and obviously networks play a big role in high-speed data connection and connecting our facilities together. So just as a level set, that's a little bit of history there.
Hey, Scott, one question I have as I see that chart is, you know, back in the day, whenever we were doing automation, it was the PLC 1774s, PLC 2s, 3s, and so forth. What's really changed in the world that's gotten us to this new transition to Industry 4.0?
Yeah, and I think new transition is the key word there, Matt. You know, we're just transitioning into that. I think most audience members, most people in this industry are going to recognize that not all while their plants are connected to high-speed internet connections, maybe back to the home office or for ERP connectivity, you know, things like that, we are not yet connected to the cloud. This idea of sensors connecting from our shop floor, from our PLCs, from, you know, maybe even sticking a accelerometer onto a big motor or piece of equipment and connecting that data to the cloud. You know, we're not there yet. We're getting there, and some forward-thinking manufacturers are, you know, they're going to the cloud. They're, you know, they want to be paperless. They want to be cloud only, things like that. But you know, what has changed, we have all of this automation from the Industry 3.0 world, and we've got high-speed internet connectivity, but there's a lot of things that still need to continue to change in terms of just our policies, our security, the way we think about the security of our data and things like that. So there's still a lot to change. We're kind of just now crossing that line into the possibilities of some of that Industry 4.0 capability.
Okay, very good, thank you.
Yeah. So just, I wanted to level set a few things here on this is my TLA slide. TLA slide stands for the three-letter acronym slide. Have a little fun with that. There is a lot of buzz out there about this Industry 4.0 and IIoT space. So just to kind of level set it, The second bullet there, IT, OT, and ICS. Matt and I were having some fun laughing about this. So we've been in this space for nearly 30 years, and the term ICS stands for Industrial Control Systems. That term has just been coined in the last few years by people that are not in this controls and automation space that we're all in, as kind of like this thing that was over here to the side. And so I just kind of found it funny that we've been doing control systems integration, MES, IoT, industrial IoT work for many years, but somebody gave it a name, and now you'll see it, on slides and in discussions as called ICS. And again, it's the space we've been working in for such a long time. When I think of IoT or IoT, a lot of these buzzwords here just come to mind. Obviously, this is not a completely inclusive list, but IoT is what we think of as Fitbits and out there in kind of the personal space or consumer electronic space, and then somebody put an eye on it, the industrial Internet of Things. As I mentioned with sensors, big data is a big deal. People talking about data lakes and data warehouses and places they can store data, and these large software solutions can then go, infer things from these large pools of data. So we've just got a lot of buzzwords in this space, and I would just venture to say that most of these things in this space, as we transition into this Industry 4.0 world, are still pretty new. There's a lot of hype around them, which kind of brings me to this next little graphic around the hype cycle. So this is a pretty famous graphic from Gartner. If you Google Gartner hype cycle, you're going to find this graphic and many other graphs that are in this hype cycle. So this is around the hype cycle for emerging technologies, but there's hype cycles for ERP, there's hype cycles for all kinds of stuff. So I just want to have everybody kind of recognize here that you may not be able to read this, but I'll point out a few things here on the slide. That smart robotics is coming up the slide here. It's kind of in the innovation phase. And this peak down here at the bottom is called the peak of inflated expectations, where things are, hyped up, but maybe not quite real yet. We come down to the trough of disillusionment and the slope of enlightenment, and then the plateau of productivity, where we actually get real business value out of things. So some of the things that are up here on the top of the curve: IoT platforms, virtual assistants, blockchain, digital twin, smart workspace, autonomous mobile robots. So, these are all on the top of the hype cycle here, where, somewhat real, and some people are getting value out of them, but not in the plateau of productivity yet.
So whenever I see that, Scott, that graph, Scott, the first thing I was wondering was, it must be a paradigm from different industries of where they might be at. Automotive might be different than pharma or food. Where do you see different industries at, and where do you see food at on that curve?
Yeah, I don't know if I agree with you wholeheartedly that different industries are probably at different levels on this curve, for sure. I don't know that I can compare food to other industries specifically, but I would say any regulated industry, such as food, pharma, things like that, safety industries, the nuclear industry, water, wastewater, they're going to be probably, I would venture to say, maybe a little bit of a laggard on this, because you get your stuff in place, you get it audited, you get it FDA validated, you get your processes in place. Sometimes we use the term the concrete dries, and boy, we're hesitant sometimes to get the jackhammer out and jackhammer it up. So while in some cases I'm sure the food industry leads because of just what consumers demand from food and food products, in other areas they might say, we deal with a food manufacturer that all their labeling is pretty much manual. It's they have a process, they print the labels, they know that they only have one place for the labels are tightly controlled, and it's a fairly manual process. So to go completely print on demand, for instance, with labeling is a change for them, and a lot of investment as well. And so while it may cut down on waste and paper and things like that, it's still a change. And so I guess my quick answer is maybe a little bit lagging other industries just because of the regulated nature of some of what large food manufacturers do, large and small food manufacturers do.
I like that analogy you used though about the concrete, how it starts to set, and once it sets hard, you have to get the jackhammer out to start changing things, and that becomes painful. It's costly, and you don't know what you're going to find once you start digging stuff up, and how much concrete you actually have to dig up once you start.
Right. Yep. It's a great question though, and I think yeah, you're spot on that different industries would tend to lead or lag on that. So last week I was at the Smart Manufacturing Conference, and SESME is the home of smart manufacturing, and so sesame.org, if anybody wants to go there. I borrowed a couple slides from my friend John Dyke, who's the CEO of SESME, and I thought I would just give to your point of kind of leading and lagging and where we are in this hype cycle, Matt.
Before you go on too much further with that slide,
Yep.
Dolores, do we have a question come in? We can't hear you.
You're muted, Dolores.
Here I am. Thank you. Yeah, a question just came in for Scott. Scott, what are your thoughts on industrial cybersecurity?
Yeah, so I was just thinking I have a slide down a little bit further that we can probably point to some graphics around that, but my quick thought is it is certainly an emerging issue. I wish I could recount the manufacturer. They probably don't wish I could, but there was a metals or steel manufacturer overseas in Europe that actually had essentially a cyber attack. Someone got into their industrial control network, into their automation network, fiddled with some of the recipe parameters, and actually crashed their, I don't know if it was their hot mill but it was a big crash. It was somebody who knew what they were doing, made some changes that were obviously not good for the equipment, and they were down for quite a while. And so I know that those kinds of stories for CIOs and plant management and plant leadership are pretty scary. And the situation with companies like Blendtec and other OEMs that serve the food industry is, they obviously want to be able to monitor their equipment as it goes out into the field and help their customers by monitoring their equipment, like the cooker cloud with Blendtec. You want to be able to get that information out of your customers and be able to help them with that. But the challenge gets to be if you have 30 OEMs that have equipment in a particular manufacturing facility, do all 30 OEMs get access to their equipment individually, or how can I combine that? How do I manage that? VPN access, lots of, back in the day, Matt, when you and I were putting in automation, we used to, people, if they were allowed, right, they put a modem in the cabinet. Yep. And the modem was to a hard line, and only the OEM had that phone number to dial into that piece of equipment. So
they'd even pull the phone line whenever we weren't connected.
Yeah, exactly. They'd walk over and say, hey, we're getting ready to connect, and they would go drop it in and connect it,
exactly.
Right? Exactly. So, and that's one aspect, is OEMs getting into, into the factories or their customers get at. But then you have, what about internal IP and knowledge inside of the manufacturing environment? People walking away with recipe parameters or batch data or quality information or specifications, things like that. Those are all super critical and top of mind for a lot of manufacturing leaders.
I think the safety threat, the security risk, is what you pointed out to, is not just the external threat of a bad guy on the other side of the world, but your internal people within the organization who have access to confidential information. How do you keep them from taking those secrets? How do you keep them from damaging the equipment with malice?
Yeah. Well, and another thing, this isn't necessarily cybersecurity we think of outside the four walls of our facilities, but in this automated world, almost every piece of equipment has a program of some sort. So if you're a manufacturer out there, you've got PLC programs, you've got label recipes and specifications, you've got even configuration for scales and other equipment. You name it, drive parameters for your pumps and even down to your HVAC and utility stuff. And so managing all that, backing it all up properly, having good security around that, because you're going to have people coming and going, whether that's maintenance folks or outside folks, and so it's very, very critical.
That was a great question. Thanks, Dolores, for bringing that out.
So my friend John at SESME, Smart Manufacturing Institute, has this slide. It's kind of a famous slide in our kind of thought leadership world. This is an actual taxonomy of a manufacturing systems. Now, I told Matt this is a large discrete manufacturer, but if there's any manufacturers on the line here, you're going to recognize your own kind of bubble diagram that would be similar to something like this, where you have likely created solutions, and they could be Access databases, they could be off-the-shelf software, they could be something that came with equipment that you bought. But the idea is that every one of these systems has its own database, has its own user interface. And guess what we always do? We still do things like this. At the end of the shift, we go gather data from our own Excel spreadsheets and some of this other other systems that are down here in the green and the orange and the purple. And we take all that and we go feed ERP systems and we gather analytics and reports, and we still print this paper and stick it on some board out there. And this is the reality of the environment that we live in today. And that's one of the things that makes this transition to industrial Internet of Things and Industry 4.0 so difficult. And so, Matt, I know you may have a question on this, but here's kind of the payoff slide here, is that legacy mess of dry concrete, as we just described,
Right,
affects every one of these stakeholders on the right, and probably more. I mean, this is a list of what, 8 or 10 roles within manufacturing, but it really affects everyone, that complicated, convoluted set of systems. And so it really demands that as we think about IIoT and moving forward in this digitization, that we really understand the complexity of this. I think the Industry 3.0, 4.0 slide said 1969. I think it was 1969 because that was the first Modicon PLC was invented in 1969. But, really the last, Matt, since you and I started our professional careers, 25, 30 years, has seen the proliferation of lots of automation and lots of equipment and software systems that make this space very challenging to just go widely implement Industry 4.0 initiatives.
And so I see that list of list of stakeholders there, and I immediately go, gosh, who touches all those different people? Because I see IT people, I see the plant manager, so I see executive level people, I see the IT people, I see the operational people, I see the automation specialists, I see a lot of different people there. And that's part of I think where I see the whole implementing the industrial Internet of Things here is, where do you start to connect all those dots?
Well, one of the you just made me think of a best practice that we often recommend to our customers when they're venturing into, and sometimes by directive of leadership, they say, leadership says, hey, I want you to play with collaborative robots, or I want you to start playing with some machine learning, or where in our organization can we try some augmented reality, or those types of initiatives. Or in our, we started 1996 as an MES systems integrator. So, just now even people are starting to think about MES integration. So we, yes, we'd love the job security, but we strongly, strongly recommend that these customers go invest in leadership within their own organizations that bridge that gap. So almost like, so there are a few large companies we know that have manufacturing IT departments or leaders. So VP of manufacturing IT. This is someone who, probably falls into the, well, I don't even want to define work. It could fall into corporate IT, it could fall into operations, but it, might report up to some other leadership role. But as we think about where we're going in the next 20 or 30 years with more with digital twins and more paperless, and in the food, industry, thinking about the farm to table and, moms and families that are interested in scanning their food product and seeing I mean, it's probably not going to be very long, and probably happening in some places right now where I can scan my QR code on my milk carton and see what cows it came from on whose land in what part of the country. And so, that is going to require a special set of skills and a special amount of leadership within those organizations, because as you said, Matt, it cuts across all functional boundaries of traditional leadership.
So is there something that I heard you say is that leadership is a big piece of that industrial Internet of Things implementation? That you're going to need leadership probably at a higher level, wouldn't you say? Because you are cutting across so many different parts of the organization. And I also see outside resources being involved too, as long as with internal resources.
Yeah. We had a project with a large pharmaceutical company, and it was a downtime analysis project, and they spent a ton of time and money along with us doing very deep downtime analysis. And sometimes you'll hear the word micro stoppage. And so we have a microwave popcorn customer, and it's tens of thousands of microwave popcorn pouches a day. And so they're very interested in a micro stoppage of 2-3 seconds, or even just small stoppages. This pharma customer, the same thing. And so because those micro stoppages, right, they can add up to downtime or blocked and starved conditions. And the challenge, so we did all this work, right? We collected all this data. We gave them the Pareto charts of what the downtime reasons were. But the challenge was the manufacturing engineers within that facility, like, okay, now what do I do with this information? Where do I go from here? And so we had a follow-on project where we did some change management consulting and really help them and the operators start to tackle these things. And here's the funny story, Matt. So we're out there on the floor, we're looking at the Pareto charts. The Pareto charts are all coming from the automation. It's kind of the one version of the truth, right? It's everybody believes it, everybody's tackling those things, and an operator says, you guys are looking at the wrong stuff. Like, what do you mean we're looking at the wrong stuff? He's like, I can tell you how this line runs good and bad. It really depends on the product that we get clear up here. The plastics that we're using at the beginning of this line, we get from 2 different vendors, and we get it from vendor A, it runs great, and we get it from vendor B, it runs crappy.
Right.
And you're not taking that into consideration anywhere in all this PLC programming you did, and all this data collection you did, and all this micro stoppage programming you did. It really comes down to what are we using at the front of the line.
Right.
And so it's a holistic problem, and it takes leadership to look at that and do the change management on top of that. It's even though we're a technology company, it's not just implementing technology to get there.
Right. So the key takeaway then, what I'm hearing, Scott, is that leadership is the starting point of an industrial Internet of Things implementation.
If you don't have support from the top and a belief, at that Sesame conference, there was an ROI presentation, and the concept of leadership's always going to want an ROI for anything they do, any capital investment or any investment that they make, and some of this stuff is very difficult to make that ROI case. So some of it, and we were kind of debating in this conference, it could be on the order of 50-50 of good, successful IoT, and I'll kind of lump what we do, MES, manufacturing execution systems, into that as well. But digitization efforts, let's just put that umbrella under it. About 50-50 that have some hard or semi-hard ROI, and the other 50% are, just we've got to do this. Matt, you and I talked about the fact that we're 30 years into some of this, automation, and the concrete's dry. And to use another analogy, the house now needs to be flipped. We've got a lot of technical debt. It's not, the house doesn't sometimes need to flip just because the cabinets are old and the color's wrong. Sometimes it needs to be flipped because there's PLC2s, PLC3s, equipment in there with no automation on it whatsoever. The only way we're going to get temperature and pressure and, things that food manufacturers care about out of it is to stick auxiliary probes and third-party hardware into it. It might just be time to flip the house and go with a new automation scheme. And sometimes that can get a hard ROI, and sometimes it can't.
Right. Could you go back to an expression you used before, the technical debt? Could you maybe spend a couple of minutes on that, and we can keep going with this slide, but I wanted you to expand that for the viewers of what does technical debt really mean?
Yeah, so you know, I think it's a takeoff of just any other consumer debt or commercial debt, right? I mean, the challenge is we don't see it on our balance sheet. So, you know, sometimes I'm on a board of a not-for-profit, and we have, deferred maintenance, and we, lots of buildings and things like that we have to take care of. And so in order to, take care of that, we've got to raise enough funds or have enough margin in our operations to take care of that deferred maintenance. And so, what we mean by technical debt, let's even go back to the labeling example I gave of a food manufacturer that we deal with is, they have a process in place. It works. There's probably better ways of doing it, but the debt that they've incurred is by they've got this manual process, and they got people trained to do this, and it's going to take an investment to get out of that debt, right? It's, whether they go with, a paperless model or print on demand model or, whatever they do, but and same thing with, I'm sure lots of customers, maybe listeners on this webinar, have equipment that may have 20, 30, 40-year-old automation on it. And someday you're not going to be able to replace that anymore, right? You're going to have to go to Menards and buy the new sump pump. In this case, though, it's not just go to Menards and buy the new sump pump, right? It might be tens of thousands, hundreds of thousands, millions of dollars to replace that equipment or to re-equip it with modern automation.
Right. Would the analogy be maybe if a bridge over an interstate, and that bridge has been there for 30 years, and then all of a sudden you because of all the truck traffic and the increased traffic over that bridge, you now have to replace it because you want to expand it, you want more lanes across it, but you realize that, oh my gosh, there's a huge amount of dollars they're going to take to now replace that bridge that you didn't account for. Is that the debt you're really thinking of trying to quantify?
Yeah. Yeah, I mean, the analogy there, though, Matt, I think somebody, hopefully somebody in a government organization would be, making some budgets for when that stuff needs to be replaced. I think we're so as manufacturers with equipment in place that we've already paid for, depreciated, and whatever, we're not building up a capital bucket of stash, to go make these investments right now. We hear about this stuff. We understand it's coming, but, I'm not sure we're planning for that bridge. In that case, your example, I think somebody ought to be planning for that bridge replacement. I'm not sure people are building up dry powder stashes of the kind of dry powder and capital investment it's going to take to modernize some of our lagging manufacturing automation capabilities.
So what I'm hearing you say, though, as a part of any sort of industrial Internet of Things implementation, you're going to be having to go back and start, in some cases, pay off that debt on that legacy equipment.
Yes. Yep. And in some cases, there may be, I saw one that came out of the Smart Manufacturing Conference. It was pretty neat. It was a company that has vision technology that literally, I smile and kind of find it funny when I think about this. So they want to make it easy as installing a Ring doorbell or a security system, right? You drop in cameras, maybe Bluetooth devices, you grab power from the facility, you got a cellular connectivity radio out to a cellular network, but you're not worried about security and cybersecurity of the facility. You got your own network, and you're literally just putting cameras over operations, could be over even a placard or a stack light. That was the part I was thinking in my mind. I was laughing that we're watching a stack light with a camera now. But then you go back to the cloud, you draw some boxes, you infer what's running, not running, you infer, I've called for maintenance, and so here's a new technology that's not super expensive, not highly capital intensive, that can give you some pretty high level running, not running, OEE type information, things like that, that maybe, that's an example where I'm not flipping the whole house, right? I'm not, trying to get out of all the debt at one time, but I'm layering on some pretty modern industrial IoT type capabilities. That's not flip the whole house, right? That's just, put a security system in my old house I just moved into.
Right. Well, whenever I hear that, though, I kind of think back to some of the projects we worked on together where we collected tremendous amounts of data for the management team to look at of operational conditions of the equipment, blocked, starved, in cycle, out of cycle, but it never got used. Do you have any thoughts about why those kind of things didn't go anywhere?
Yeah, let me defer that one for a second, Matt. There's a couple other slides here that I might be able to answer that one. So jot it down, make sure I don't forget to answer it, okay? I'm gonna get through just a couple more slides, and I have a little model for how to walk, kind of crawl, walk, run. And so this, since we've been kind of talking about this last 20 or 30 years of Industry 3.0, I just want to remind everybody this stuff's not new. So I laugh when somebody says, Industry 4.0 or IIoT. Our mayor here in the town of Fishers like to say that Flexor was doing IoT before it was called IoT, which we were. I'm a Purdue grad. This was invented at Purdue University, called the Purdue Reference Model. We'll send out these slides later to everybody. There's a link on this slide to a Wikipedia article that kind of describes the history of the Purdue Reference Model. Many of you in this space have probably seen that. Here's our kind of drawing of the same kind of this is the ISA 95 model architecture now. It's been adapted by the ISA organization from that original pre-reference model. This is our kind of logical stack from 0 through 4 of where things live in this. So, when we talk about IoT or IIoT, almost everything in the stack is in the IIoT space. I guess one could argue that ERP at the top end there is not an IIoT software application, but this is the slide I was thinking of with the cybersecurity. So you'll see this little rectangle here, the firewall between corporate networks and plant level networks. So, just as another little nugget for folks on the call, if your manufacturing facilities are already starting to think about a firewall between industrial control system networks and corporate networks, you really should start thinking about that. That is a huge issue. We dealt with a manufacturer here not too long ago. It was actually in the furniture products industry, and they had some pretty old, I think like Windows 95 CNC type machines that didn't have a firewall there, and they got a virus, and they weren't patched, they weren't up to date, and it brought them down for a while. And so, needless to say, they went this direction quickly. So,
isn't that how a retailer got in trouble? Where they went in through the hackers went in through the HVAC.
I think it was I think it was Target, maybe.
Was it Target?
I think it was Target went in through the HVAC system. Yeah.
Yep. I thought they even had the stolen credentials of HVAC of the contractor, so they really weren't even hacking in.
Yeah.
And it was able to bridge through the HVAC system into the financial systems.
Yep. Well, and there's another case. I think it was Iran or Iraq. It was somewhere over in the Middle East where, one of the first cases of a PLC, virus, of somebody getting in all the way down into a PLC and putting a virus in a PLC.
So that was Stuxnet back in the day.
Yeah. So back to your question of, maybe getting started, I thought I'd kind of throw out this walk before you run kind of model and just describe for people maybe a way to get started. Because we've already, Matt, you and I have already touched on 3 or 4 different, getting the jackhammer out or layering on the security system. We've used all these analogies. But this is one we use with some of our customers, just remembering that there is a maturity ladder, there is a sophistication journey that has to be taken as you go up this maturity ladder. And lots of customers want to jump all the way up to level 4, level 5, right? It may be, to go back and use my label printing example, maybe they want to jump all the way to, I don't want my label room. I don't want Sally printing the labels for the whole operation every day, and having to deal with, coordinating all the logistics of all that. But there's steps that have to be taken in order to get there. So let's just take that example. Let's just take label printing and say we're going to print them on demand. So we're going to set up some sort of a IIoT and software solution that allows us to enter the lot that we're running, the recipe that we're running, the batch that we're running, the case code. It basically has all the recipe for everything that's going to get a label, from best of use by date to case labels to whatever. And we want to propagate that down to the proper intelligent devices in order to have them printed properly, because we all know if you print that wrong, it could be a nightmare. So the challenge gets to be, if the problem today is if we fat finger that, if we make a mistake when we're entering that manually into the inkjet printer or whatever, that we have those errors, we have to recover from that. But even if we automate that, and some system is feeding that automated system that we put in place, and that system gets bad data, or someone in purchasing, or someone in order management or scheduling or something like that makes an error, and then we propagate it automatically to all of the equipment down there, we have an equally bad problem, maybe even a worse problem, because we might have labeled even the product with the bad best of use by date, and a case and hundreds of cases with it as well, right? So it demands that we take a look at the whole operation, and understanding that it's the same rule applies: garbage in, garbage out, right? Bad data, or these steps, maybe 2 and 3 and 4, have to be accurate before we don't want to automate a bad process.
Mm-hmm. Do you, I guess whenever I see that though, whenever you're meeting with engagements with your customers, do you try to drill down into what is the real problem, where maybe the labels isn't the real problem, maybe it's some other piece of bad data? How do you get to that piece to understand the real business issue, the real risk? Maybe it's an allergen problem they're trying to solve, not just a label problem.
Yeah, I think the key word in there, Matt, you mentioned, is the business problem. So oftentimes we get called in and people say, my executives want digital dashboards so they can see how the lines are running. And that they've already jumped to the conclusion that that is going to be the solution that they need. And we try to take a step back and say, well, what's the business problem you're trying to solve? How are we going to measure success here? If it's an allergen problem, obviously things like escapes or allergy problems or quality issues with the customer, finding, quality issues with your product, those are pretty big deals. But we try to get to the business problem first. We have a process called a business value map process, where we take a look at the business problem you're trying to solve, and then what are the roles, the technology, the automation, the systems, maybe the people that feed into that issue, and then we try to go pinpoint the highest leverage place to go start solving that problem. But for us, it goes back to what business problem are you trying to solve.
And I see that just whenever I'm meeting with my clients for the first time, we're talking about different problems they're trying to solve as part of their process, because everybody has a unique challenge that they face, and is trying to understand those unique problems and then figuring out, okay, how can the equipment, how can the software solve that problem?
Yeah. I guess the point there is, back to my, we talk about leadership being a key component, and back to the change management piece. We may think we have a way to solve the problem, but I guess engaging others to make sure that is truly a good way to solve, well, the right problem to solve, and then the appropriate way about going and solving it.
Mm-hmm.
I just as a way, we talked about it, this webinar being around IIoT, and I wanted to just point out one way that we like to talk about getting started. This slide was deeply animated, but I figured for the webinar I would cut out all the animations.
Thank you.
It was, but you get the idea. So the idea that what we like to promote is start with a simple implementation. That's the top row, with just a couple of gears and a couple of features, if you will, mm-hmm. in multiple facilities or multiple lines, as opposed to lots of features down at the bottom in the blue, and only getting to a couple of facilities or a couple lines. We've been doing MES implementations for 23 years here at Flexware, and I can tell you that there's probably only, I'll count this sometime, but it's on one hand, the number of customers have gone to more than 3 or 4 facilities in their fleet of plants, and spreading digitization, MES solutions, now we call it, IIoT solutions, in the deep functionality model. If we go down below to the blue and you have a lot of functionality and you're trying to go to tens of plants, hundreds, maybe not hundreds, but lots and lots of facilities, it's very, very difficult. I mean, you have to have deep pockets, a huge resolve, a huge leadership commitment to that, because it's use another analogy, I call it ground warfare. It is putting boots on the ground and a lot of effort and a lot of work and a lot of change management. It's akin to an ERP implementation. So anybody who's been through an ERP implementation knows that that's ground warfare.
It's ground warfare. It's a tough battle for sure.
And it's tens of millions of dollars, depending on the size of the organization, right? It's, tens of thousands to tens of millions, or hundreds of millions in some case. And so the same thing, so I want to caution people not to just go crazy with IIoT or IoT or plant digitization efforts. My recommendation: get leadership involved, stand up a group that's focused on this, that's cross-functional, start small, try to replicate it across multiple lines or facilities, learn, fail early, fail fast, learn a lot, and then add features and replicate that across, your lines and your facilities, and maybe more of a layered fashion, because if you can be consistent, it's like, go to your pick your favorite franchise, right? Taco Bell, Starbucks, Subway. If you can be consistent, it can be a lot easier to implement. But the challenge in our space, back from that taxonomy slide, is every plant is different. And so that ground warfare, boots on the ground, integrating that stuff gets very, very challenging.
That makes a lot of sense. What I'm hearing you say, though, is start simple.
Yeah.
Pick some things you can get a quick win on, maybe.
Yeah.
And show the value of the implementation, and then keep building on that success. Otherwise, you're going to get bogged down in some sort of quagmire, in a big engagement that with an undetermined ROI.
Yeah, we call it quick time to value, right? So every executive loves quick time to value. So, if you can do a $20,000 pilot, show the value of that, and then figure out how we're going to replicate it. Because as an example, we have a customer right now that wants to do a custom MES solution, and they want to start here in North America, and then they've got a plant in China and a plant in Japan. And the plant in China and the plant in Japan have different automation vendors, right? One Mitsubishi and one's Omron, and the one here in the States is Rockwell, right?
Sure.
So
how do you do that?
We want to write it so that you can fairly easily go to those other facilities, but there's still going to be middleware implementation that is required to make that work.
For sure.
So even a $20,000 pilot, while successful in showing business value, may not necessarily translate to your second plant, your second line, super easily. You got to take that into consideration.
I like your expression there, though. Whenever you're thinking about industrial Internet of Things implementations, at the quick time to value.
Yeah.
I think that's a huge takeaway for the viewers, is making sure whatever you do, whatever you pick, make sure you're looking at a quick time to value.
Yeah. I mean, otherwise it's a hobby, right? You're just having fun.
Just having a hobby. And we don't need hobbies. I got enough hobbies.
Yeah.
Okay.
I think, so just summary slide, and then we want to open it up to questions. So I think we just talked about this. Start small, deliver value, that quick time to value.
Quick time to value.
Learn early, learn fast, right? Educate yourselves on the risks, and kind of, identify your own maturity journey for wherever you're heading, and things like, we talked about, like, I use the label example, but understand what else has to be in place before we can leverage some higher end technology. One thing, Matt, on that one that you and I talked about prior to the webinar is just in the realm of sensor data and big data and all that, that context is so important. People think about, I'm going to ship all of my batch data to the cloud, and I'm going to figure out what my golden batch is, right? it's got to be with context. There was a IIoT startup here in our backyard, and they were going to put sensors in plants, and they were going to poke a cellular antenna out, and they were going to collect this data off these machines, but they were calling it an MES solution. I'm like, wait, hold on a minute. You might know up, down, part count, or flow. You might know some of these things, right? But you don't know what shift you're on. You don't know what product you're running. You don't know whether Larry or Sally are running the machine. You don't know what plastic you're running on the beginning of the line. You don't know 1,000 things about context. All you know is what you can get these few data points off this machine. And context in this world of IIoT and big data is so important to correlate this stuff back to real actionable data. So that's another kind of key takeaway for people. It's just when you're collecting this data and you get excited about data lakes and big data and IoT clouds and stuff like that, is that context is so important.
And to get back to the question we talked about earlier, some of the project we worked on together, that's why the data didn't go anywhere. Even though we created reams of it, it lacked context.
Yeah.
The data actually lacked context. And it's no different than a watch I used to have for when out running. You don't know about elevation changes. You don't know about the distance you actually ran. But now with my Garmin, gosh, I get elevation changes. I get the temperature. I get all the distance information. So you can add context to that time to understand why my time sucked that day. Why didn't I do very good?
Yeah. Yep. And it's going to be more and more critical. One of the things the Smart Manufacturing Institute is really focused on, they call it democratizing, this smart manufacturing stuff. And so, for those techies on the line, you understand the term OPC, that stands for OLE for process control, but it's basically, I describe it as the printer drivers of all automation equipment, right? So it's, if I want to be able to talk to that Mitsubishi Omron and Rockwell PLCs, I'm going to use these off-the-shelf drivers called OPC drivers. And that is a bit of standardization and democratization of being able to connect to that. But still, the amount of effort and the time it takes to go hook up OPC servers and drivers to all of this equipment and get the contextual data and be able to do something with it. And right now, I'm just talking about read-only stuff, Matt. Just gathering data out of these systems and doing something with it, much less, MES, much less the enforcement of error proofing or batch management, or, where we're trying to more closely guarantee a golden batch or, a quality product coming out the door. It's just, so the Smart Manufacturing Institute is really trying to figure out how to democratize that by having some standards and platforms and making it easier to, gather context up and down, in and out of our facilities or in and out of the cloud. And so I'm excited to be a part of that and just see where they might be able to make that easier for all of us.
So a few key words I heard from today, Scott, and we can wrap this up and hand it back to Dolores here, was leadership is important in the implementation across your entire manufacturing space. Start small, that's what I heard. Quick time to value. And then the big piece too is whatever sensor, whatever data you start getting, you have to be able to contextualize it. You have to be able to have context to that data. Otherwise, it just is a hobby.
Yeah, and I think one other thing I would add to that, Matt, is just realize the complexity of the environment that we have all created together over the last 30 years as you venture off into these challenges. There's going to be solutions like we talked about with the camera solution that's going to be helpful on top, but there's also going to be stuff we're going to have to chip away at the foundation and get the jackhammer out and kind of refoundationalize some things. But realizing that, back to that taxonomy slide, the complexity that we've all got in our facilities, and I don't care if you're a $20 million soup manufacturer or Nestle, right? I mean, the complexity is there in every one of our facilities.
So there's a technology debt that we have to be aware of going into this.
It's there. I mean, okay. I challenge a $20 to $50 million food manufacturer to count up how many Access databases or SQL Server databases they have in their facility. It will be no less than 10 to 20.
Wow, that's incredible.
Yep.
Dolores.
Yes, I have a question for Scott. How do you view the use of edge devices to bring information to the cloud?
Yeah, so one could argue that all of that automation that we put in our facilities, as I just mentioned, over the last 30 years, they're all edge devices. They are out there in the facilities, in these ICS, these industrial control systems, and so I think what will be interesting, a lot of, I'll call it newbies in the IoT world, would call like a Raspberry Pi or an Arduino board a more modern edge device. And so you can go buy so what we've heard stories of happening is, a leader of a manufacturing facility say, hey, we got to get in this IoT game, go figure out how to implement IoT. And somebody, the fresh out college grad will go buy the $35 Raspberry Pi off the internet, and they'll go hook it up and put it on their Wi-Fi and start collecting data. And that's very valuable proof of concept type things to do. I love the passion around it, the directive, and it's kind of the fail early, fail fast stuff. But we've also, it was just this week, my VP of Business Development was telling me about a homegrown, hacked together edge device solution like I just described, that somebody tried to proliferate across the whole plant. And so I guess my caution there on the question, Dolores, is to make sure you're building something that's scalable. I would look at some of those things like Arduinos and Raspberry Pis as, kind of the proof of concept. Doesn't mean that they can't be the hardcore hardened solution for edge devices for IIoT, but just, know what you're getting into and understand whether or not it's scalable, maintainable, and something that you can build on.
Are you muted, Dolores?
I'm testing your lip reading skills. Sorry about that.
I'm an engineer, not very good.
Another question. Are there tools/algorithms available to plug in a plant's characteristics and operations, manage expectations, and project a timeline for implementation and timelines for ROI and costs before taking the leap?
That's a loaded question. So we're dealing with a aluminum can manufacturer right now that was looking across 9 facilities, and it was the ground warfare. We've gone into those facilities, we've opened up cabinets, we've gone and done assessments. One thing I like to remind people is that if you're going to drop an Ethernet cable to a device, a PLC, or a device on a line, you better budget about $1,000 a drop. By the time you get the man lift out there, the cable, whether or not it has to be in conduit, punch a hole in the cabinet, wire it up, land it back in a networking cabinet somewhere, give it an IP address. At least $1,000 a drop. And so and most of the technologies that we're dealing with, talk about right now, it's not like you're going to stick your little Wi-Fi module on the side of the cabinet and magically suck a bunch of data out of the cabinet. We're not there yet. So we're still talking about a lot of hardwired devices. Now, again, back to my camera example, that's supposed to be, trying to be as easy as implementing a security camera or a Rain camera in your house. But when somebody's counting the cost, Dolores says, I think the question's kind of asking, kind of budgeting, and how do I go about getting started? If you don't have a lot of digital infrastructure in place already, wiring up, we've even kind of talked lately about the terms of just simple EKG pads, right? I want 2 stickers that just tell me whether my heart's beating or not on my lines, right? Am I running or not running? That would be ideal if I could just drop those things on and put a couple stickers on the line and say, yes, I'm running or not running, and good or bad parts. But even that is pretty expensive when you start thinking about doing it to every asset, to every line, to every machine. And so some level of assessment is what I would recommend people do to get started. There is not a rule of thumb. It really depends on how antiquated your equipment is and how much you're trying to get out of that equipment in terms of data. And we can, there are many companies like us, systems integrators, that can give you some swag, some estimates on that, once they kind of hear about what you have. And one thing I would recommend that everybody, in order to have people answer that question easier, is start with a simple Excel spreadsheet. And I have a drawing we do called a plant nervous system. And the plant nervous system is literally, in fact, let me just go back for everybody just 2 seconds. Literally take this, take this logical diagram of the S95 diagram here and draw this picture for your facility with every PLC, every label printer, every intelligent device that you have, and that's your plant nervous system. Draw it and what level they live in. You don't have to go down and do every single sensor, like every single weigh scale or every single flow meter or anything like that, but at least at the level 1 and 2, the PLCs, the smart drives, the operator interfaces, the human HMI and SCADA solutions, and get that as a baseline. And then beside that, have an Excel spreadsheet that shows I've got 50 PLCs in my facility, and here's their IP addresses, and if they're on the network, if they're not. And then I've got these 30 machines over here that aren't connected to anything. They've got a red lion counter on them, and that's their only kind of operator interface, is a counter or some local display of some sort. So that will help someone like us, or Mike, I can use the example of standing up an organization inside your facility. That'll help someone like an MES leader or a digitization leader try to get a grip on what the cost might be to get started. I know it's a long-winded answer, but hopefully that helps people get started.
Great, thank you, Scott. Matt, I don't know if you have any questions.
No, I think we summed it up pretty well. We had some great questions. I think we're at a point we could wrap up this webinar.
Right, and the only other some comments or questions that I received was to get your slides and your contact information. If that's okay, I can send that out after the webinar.
Sure. Yep, we can PDF the slide deck for everybody. Hopefully the couple links that we dropped in there will work and make it available for the members.
Awesome, wonderful, great.
Thank you so much.
Thank you, gentlemen.
Thanks, everybody.
Yeah, I want to thank Scott and Matt so much for this. This is our first webinar of our new technology network that Matt heads. Scott, that was wonderful. Thank you for all of that great information. And thank you to the attendees for taking the time out today to join us. Have a great rest of your day, everyone. Thank you.
Thank you.
Thank you.